Hello, students. Oh, I got to go ahead and fix this really quick. Let me go ahead and fix this. It's in a presenter view. So let's go ahead. Now we'll be able to see it better. 1, 2, 3. Okay, one more time. There we go. Now we can see better. Okay, guys, welcome back. It is Mr. Campbell here with day 7 of Unit 2. Again, the quiz is going to be posted ASAP, and I will give you the whole week to finish that. No worries. You should, though, have completed your vocab from last week, and you should have completed the notebook check hopefully soon. You guys have one more day to turn those notebook pages in. That is pages 3 and 4, the layers diagram, as well as the layers description needs to be included in that, and details are included on Canvas. We have our, again, other updates in that, guys. I think the same as usual. We'll just keep having quizzes and assignments. I've still got to post the workbook pages, so those will be extended as well a little bit. So make sure, again, you're getting up to date on your missing assignments. You're staying ahead of things. You're keeping your notebook up to date. We've got number 1, what are the 3 types of heat transfer and what are their differences? Provide examples. We saw that in our Bill Nye video last week, right? And then 2, what exactly is Earth's magnetic field and what does it help create? So let's go to number 1 here, pause the video, write these out on page 9 or 9B, and then go ahead and answer them on your own and see how close your answers are to mine. Okay, if we look here, obviously if you remember, I kind of simplified it. We wrote it out, we drew it out last lesson, right? We've got conduction, convection, and radiation, right? Conduction, convection, radiation. They're all heat transfer, all the transfer of energy, but they all involve different mediums. So for conduction, it's by direct contact. So say you have a stove touching, you have a pan, like you see down here, right? Here's a good illustration. You have a metal pan touching a heating stove. That is conduction, heat moving from one object to the next by touch, okay? And then secondly, we have convection. Okay, so what is convection? Convection is heat transfer through molecules, the mass motion of molecules, right? An example of that would be steam. So for example, water molecules, steam, humidity, things like that. Again, that is convection. Anything with water, molecules, that is convection. Next thing we have is radiation. Lastly, guys, again, heat through electromagnetic waves. That's like a lamp or maybe the sun's radiation, the sun's rays. All of those are examples and descriptions. Now for number 2, okay, what is the magnetic field or the shield around the Earth? Again, this static shield that's kind of invisible, but it is around us, creating our atmosphere, okay? This is the shield that's created by the metal core, specifically the iron core that surrounds and protects the Earth. So again, metal core that surrounds us, protects the Earth, creates our atmosphere. So without that, we wouldn't have the atmosphere, we wouldn't have clouds, we wouldn't have rain, none of that. Our planet would be a dry, barren planet with no life and no water and so on and so forth, okay? So ignore that. Your table of contents shouldn't be new, I don't think, but if you haven't updated it, again, pages 9 through 11 should be Earth's magnetic field and heat. Moving on, guys, I've got a quick video, our last video on tsunamis. So go ahead, please write this down on page 7 or page 9, wherever you do have space. It should say, how fast and tall can tsunamis get? How fast and tall can tsunamis get? A really, again, kind of as we got into earthquakes a little bit, a really informative, interesting video that really details tsunamis. So I'm going to go ahead and post that on Canvas. You need to watch that on your own, but I will show you guys, as I usually do, a little intro, a little sampling of that video, right?
To the Greek city of Potidaea, the tide retreated much farther than usual, leaving a convenient invasion route. But this wasn't a stroke of luck. Before they had crossed halfway, the water returned in a wave higher than anyone had ever seen, drowning the attackers. The Potidaeans believed they had been saved by the wrath of Poseidon, but what really saved them was likely the same phenomenon that is water and raising it above the normal sea level. But gravity pulls it back down, which makes the energy ripple outwards horizontally. Thus, the tsunami is born, moving at over 500 miles per hour.
And I just gave you the answer to the speed, right? So 500 miles per hour is the speed of the worst a tsunami can get. You guys need to watch on your own how tall they can get, which is actually a lot taller than you may think. So be sure to watch that on your own. That will be included in your Canvas post here later today. Okay, let's go ahead and move on to where we left off. You should go back to pages 10 or 11, wherever you have space. It should be hopefully page 10. We're going back to some magnetic field stuff, right? We left off on density last time. I have 3 slides I'd like to show you and a few practice questions as well. Uh-oh. Okay. So our first little, let's see here. Yeah, so we'll do our question a little bit. I want to write a little bit about heat. So like, what is heat? Again, we're only going to write what's in yellow. Heat, so go ahead on another section on page 10 or 11. Again, we're on page 10 or page 11. I want you to write heat is the energy transferred by convection, conduction, and radiation. Heat, we know heat is hot. We know what heat feels like, right? But what is it in word context, right? What is the meaning of it? It's just particles moving around, right? The faster the particles, the hotter the object may be, okay? And then how does heat impact matter? Okay, heat's going to change things from solid, liquid to a gas, right? So the hotter something gets, the faster it's going to change those phases. So it can change your physical state. When a solid reaches the temperature of its melting point, it can become a liquid, then boiling point, etc., etc. So heat is all about changing states of matter, so on and so forth, okay? So that's what you need to write down for heat. That needs to be on page 10 or 11, wherever you have space and room. We have space and room. Okay, our maybe one of 2 practice questions of today, simply a quick recap. And again, it's going to be is it P wave, S wave, or surface wave? We don't have the cups with us, obviously, because we're not in person. But you need to tell me, is it P wave, S wave, or surface wave? Number 5, which seismic wave is unable to travel through liquids / the outer core? Again, which one is unable to travel through liquids / the outer core? Which one is going to be? P wave, S wave, or surface wave? It's going to be S waves, guys. The second option. Again, that's P waves travel through everything. Surface wave only travels through the surface. It is only the lithosphere. But S waves are going to be the ones that can travel through up until they reach those liquids. Cannot travel through the liquid outer core. Okay. Our next thing I'd like you guys to jot down is our next video question. Why does the Earth get hotter the farther underground you go? So the idea, again, write this question on page 10. The idea is that, okay, you go in a cave, the caves are going to get colder the farther down you go. A lot of water, it gets cool, there's no sunlight. But if you dig deeper through the cave, if you dig deeper than the cave itself, the ground begins to actually get hotter. Why is that the case? You're going to watch this video, guys, on your Canvas post to answer that question, and I'm going to go ahead and show you a sample right now.
Kelvin was confident this idea would allow him. Somehow, the hot temperatures just under Earth's skin made it seem to Kelvin that our planet was pretty much fresh out of its cosmic oven, when we now know that it's 4,500 million years old. Kelvin's error is usually attributed to the fact that he didn't know about radioactivity, which creates a ton of heat in Earth's core and helps.
Okay, so you're going to have to go ahead and answer that on your own by watching all that video that I will post to Canvas, so be prepared for that. And let's go ahead and move on to our last 2 sections of today, guys. Just write down this in yellow, guys. Again, now make the title Earth's Magnetic Field. Again, we're going to continue on page 10 and then add more as we go to page 11, okay? So Earth's Magnetic Field, generated by the movement of the liquid outer core, okay? So we talked about the metal iron inner core, and this movement occurs through convection. So you've got, not only do we have, guys, we not only have magnetic energy flowing through our planet, we've got we got heat flowing through the planet. The planet is very much alive. It's very much active. It's not a living thing, but it's got so much energy flowing through it from all different areas and all different facets, right? So again, so the Earth's magnetic field, it's also generated by the movement of the liquid outer core. This movement occurs through convection. Another really important topic to know is heat. How does heat work in the atmosphere, okay? Always understand, heat's going to rise because it has lower density, right? If you think of an air balloon, what do air balloons do? They're called what? Hot air balloons. Hot air balloons do what? They rise because the air in the hot air balloon is hotter than the atmosphere, right? And what happens? Why is this the case? Because when particles get hot, just like people would do if they get hot, they're going to spread out. When those particles spread out, they become less dense and it rises. So hot air rises because it is less dense. And when air gets cold, what do? Particles like we would huddle up together. They huddle up together, and that causes the hot air balloon, that causes that air to sink. So hot air rises because of low density. Cold air sinks because it has high density. This is the principle behind convection. So go ahead and write that down on page 10 or 11 wherever you have space, okay? All right, we'll get into that importance on another date, guys. We'll get into that video tomorrow. Last thing I want you to write for the day is convection currents, as we did mention it, okay? Where do those convection currents occur? Again, they're also kind of driving the magnetic field just a little bit, specifically in the outer core. These currents we're going to talk about occur within the middle mantle. Again, these are the currents. These are the currents that were transferring heat to the crust. They're also the currents that were moving the plates. They're causing the continents to move, causing the plates to move. Just put down what's in yellow, guys, on page 10 and 11. These currents occur in the magma, okay, and they drive plate tectonics. They're going to be created from radioactive decay in molten rock. Again, magma is molten rock, specifically located in the asthenosphere. Okay, so not only do you have in the layer there in the middle mantle, but the spheres that they're located in are the asthenosphere and the lithosphere. Again, in the asthenosphere and the lithosphere. That is the idea right there. Again, make sure to write that down on pages 10 and 11. In case you guys didn't know, magma versus lava, what is the difference? Okay, magma is the molten rock when it's underground, when it's inside the earth, whereas lava is the molten rock when it has resurfaced, when it has come out of that ground and it is now at the surface. That is lava. Again, magma's in the ground, lava is coming out of the earth at the surface. Okay, let's do our last question today, guys. Which of the following best describes heat and coolness? A, B, C, or D? Read through each. It has to do with whether it sinks or rise, and has to do whether it is low or high density. Think about it. Take a moment. Pause the video. Okay. Play the video. Find out the answer is going to be D, guys. Heat rises with lower density, cool air sinks with a higher density. That concludes our lesson for today, guys. Looks like I might not be able to post this till after school today, so apologies for that. We'll get that all situated. The quiz will be posted after school as well. We'll get it all taken care of and done. If you have any questions, again, always call me on my Google Voice account during the period, or leave me a message on Canvas Messenger, and I'll get back to you within 24 hours. Mr. Campbell here, signing out.